this is the energy mix in China. We can saw that this is the coal. The coal will make up about it is about nearly 80% of the energy mix in China. Therefore, we already know that coal is not sustainable energy. And sustainable energy like solar, wind, geothermal, and biomass development in China, it is increasing, but it still didn't meet the requirement. This is the transportation energy mix. Currently, the fossil fuels are still occupied more than 90% of the fossil fuel. Therefore, this is the reason why the Chinese government they encourage the customer and industry to use to transform from the traditional IC engine to the electric vehicle, especially the battery vehicle, because what you want to do is reduce the CO2 emission to meet the requirement in 2030. Yeah, we also saw that even though China go to the electric vehicle, but we saw that the electricity of the power mix in China, the coal also will occupy the 67% of the coal in China. Therefore, the Chinese government still have more work to do to make the energy it is carbon neutral. Yeah, since we briefly introduced some automotive powertrain configuration. The first one, it is a traditional IC engine. We didn't say too much about that. And this is the two configuration of the hybrid vehicle. This is a hybrid electric. This is a range extended. The significant difference between them it is that here, hybrid vehicle, the plug-in it is not necessary. The electricity can be produced by the IC engine. For the range extended, or maybe we call it a plug-in electric vehicle, it must have contain the plug-in charger. That means IC engine it is no longer the sole source of the electricity. The customer can use their house electricity to plug in to charge their car. And this is the battery electric vehicle. It is that it is totally removed the IC engine. This is the fuel cell. Yeah, it is also another type of battery. It will use, especially it is use the hydrogen as the energy sources. And we will discuss. Yeah, we will here. We will discuss about how this hybrid technology and electric vehicle can provide a new development opportunity for the IC engine. Let me see. Yeah. Okay. This is the very old IC engine. Is a high. This is the load and engine speed. Its operating range is very wide range and is a high efficiency. It is usually at the medium speed and high load. Now we optimize it, extend the high efficiency region, and further extend it using advanced low temperature combustion technology and other turbocharger and any types of to extend. This is to extend is a high efficiency working range, operating range. But how far we can go in the future? This traditional engine development procedure. But if we introduce the electric vehicle, especially the hybrid vehicle, including the IC engine, they will provide a new opportunity for the IC engine to stay alive in the future. We will saw that the IC engine will no longer to work in the whole range. It just need to work in this range. If they use if they can use the plug-in hybrid vehicle to use a more powerful electric motor, they will extend the electric motor operating range, will collaborate with the engine. That means the engine no longer will work at the whole of this working efficiency. They just need to stay here, stay at the high efficiency region. That will maybe it is will in the future maybe fix at the particular maybe a few single operating conditions that it is enough. This is the reason why we question there of the maybe the in United States the Supertruck project. They claim that their diesel engine efficiency can reach 50%. Some researchers question that, okay, you just reach 50% at this single point, you are not in this whole operating range, it is useless. But if we use electric vehicle, especially hybrid vehicle, it is useful because we just need to fix on this point. We don't need to run out elsewhere. Okay, we will. This is the this is the hybrid vehicle. We will saw that especially this one. This is in the future. In the future 20 or 30 years, the powertrain technology like IC engines, hybrid vehicle, or battery electric vehicle or fuel cell, that will be diversity. IC engine no longer be the king of the vehicle. Yes, and especially we saw that in the Euro Commission and China, we will saw that the technology it is a little different in these two regions. In EU, the hybrid vehicle will occupy nearly 68%. But in China, the Chinese government it is more prefer the battery vehicle. We will go further why they have this difference. Yes, and we saw that this is the scenario. This is scenario from the United Nations. This is two different prospective projection models of the future for the light duty vehicles. We can draw a conclusion. It is that no matter which type of predictive model, we can saw that hybrid gasoline, hybrid vehicle contain gasoline engine, or the battery electric vehicle will be the dominant technology of the powertrain in the future 20 years for the light duty vehicle. Yeah. And also, and for the heavy duty vehicle, because we already know that the battery have is volume of the electricity. It is not enough for the long distance cruise. Therefore, for especially and its power density, it is not very high enough. Therefore, in the heavy duty vehicle, there will be another story. This data it is from Yuchai, which is a heavy duty vehicle manufacturer in China. We can directly go to see that in 2030, we can saw that mainly it is the yellow one. The yellow one, it is the hybrid vehicle and also the battery vehicle, including the fuel cell, will occupy the market share. Yes, if it is a hybrid vehicle, contain the IC engine, it will contain the diesel engine. And if it is for the battery, it will be the fuel cell. It is not the Lion battery for the heavy duty vehicle. Okay, this is the Toyota's roadmap. I think this is they illustrate the conclusion. It is that for the passenger car, it will be the plug-in hybrid vehicle or the hybrid vehicle will dominate in the passenger car. For the commercial vehicle, that will be the fuel cell vehicle or the hybrid vehicle, which will contain the diesel engine. Of course, for the mini vehicle, the battery electric vehicle can be used because it didn't require a very long distance cruise. You just need to drive to the university and go back your home. Therefore, the battery, it is enough. And this is, and we see here, if we comprehensively compare the environmental and performance, economic, and the impact of this different technology roadmap, we saw that the hybrid vehicle and the plug-in hybrid vehicle will have a very good balance between the economics and its performance. And also it can reduce the pollutant emissions compared to the IC engine, and it will be more cost effective than the fuel cell and the battery, because more exactly for the fuel cell vehicle, you need to supply the hydrogen. The hydrogen, it is even expensive, more expensive than the petroleum you are now using. Therefore, at least in my perspective, hybrid vehicle and or the plug-in hybrid vehicle will be the dominated in the future 10 or 20 years, and also it will keep IC engine stay alive. And this is the energy efficiency of the IC engine. It is discussed how it is illustrates how to increase the efficiency of the IC engine. This is the pathway. It is that to improve the combustion efficiency, reduce the unburned hydrocarbon and CO emissions, and to improve the isolation performance and reduce the heat transfer to the cylinder, to the coolant, and otherwise. This is what LTC, low temperature combustion, they are doing. It is to reduce. It is by reducing this loss, and this pumping loss and the pumping loss. It is complete by introduce some new cycle. For example, for the spark ignition engine, now more of them, they are using the Atkinson cycle, using the VVT technology, the variable valve timing technology. The abbreviation is VVT. They use it to improve the cycle efficiency. And this is another conclusion. It is that for the spark ignition engine, it is very appropriate for the range extender electric vehicle. More exactly, it is a plug-in electric vehicle because it didn't need a very high power density engine. Therefore, maybe 2-cylinder or 3-cylinder or 3-cylinder gasoline engine, it is enough. And here, this is the Shell, and this is the Shell's technology roadmap. How to, because we know that Shell, it is is usually it is the supplier of the petroleum supplier, but we already saw that Shell it is seeking to start the transition from petroleum to the sustainable fuel. For example, they use the fuels production from the biomass. They use gases and liquid fuels, just like Michael said, to produce the syngas or the liquid fuels. Yes, using the IC engine. This is very excellent in Shell. We already know that, but it also uses some sustainable energy like the wind energy and the solar energy to produce the electricity. To electrolyze the water to produce the hydrogen. This is the reason why I say hydrogen is very, very expensive. This hydrogen, it is unlike Martin said, it is not in this case not used in the IC engine. It is used in the fuel cell because in the Shell's plant, the best usage of the hydrogen, it is not in IC engine, but to supply the energy source of the fuel cell. This is also the reason why currently the fuel cell is a very expensive technology. And also this electrical power can be used to the Lion battery. This is excellent. Tesla already do an excellent battery construction. Yes, but we can saw that here in this whole picture of the tank to view. The Shell still incorporate the IC engine into the powertrain technology. That means Shell also favor the hybrid vehicle will be dominated in the future. Yes, this is, for example, I already mentioned that in China, even though they transfer into the to the electric vehicle using the fuel cell or the battery, but since in China more than 70% of the energy mix is from coal, and is a majority of the electricity production, it is from the coal. Therefore, Chinese government now it is still encourage the carbon neutral fuels. That is the lab production of the CO2 is 0. Yeah, we take Ecofuel from renewable electricity as a case study. Yeah, first use some sustainable energy to produce the electricity, to electrolyze the water, to produce the hydrogen. Use the from here they capture the CO2 carbon dioxide in the atmosphere, and then to manufacture the syngas, and then use Fischer-Tropsch technology, then go into to produce the liquid fuel. But I'm sure this technology roadmap currently it is very expensive, because you see here, this is the how to produce the hydrogen for the fuel cell to electrolyze the water. It didn't stop here. It go further. It go further to produce the syngas, and then use the Fischer-Tropsch. 2 more steps than the fuel cell. That means this technology it is even more expensive than the fuel cell technology. But at least it provides a pathway how to produce Ecofuel from the renewable energy. This is one type of pathway. Yeah, this is another carbon neutral fuel. This is the Ecofuels from plastic waste. From plastic waste or the biomass feedstock. They use the plastic waste to use pyrolysis and gasification to produce the bio oils and the syngas. If we saw the syngas, it is CO, carbon monoxide, and hydrogen, and then use the Fischer-Tropsch process to produce the fuel. Now it is the majority. It is the methanol and the ethanol and the mixed ethanol and also the diesel. And this plastic waste, it is a pyrolysis process to produce the bio oil and then go into the hydrocracking and go to gasoline and diesel. This is another technology roadmap of the carbon neutral fuels. This is the perspective of the Saudi Aramco. It claims that because electric vehicle, it is gain more attention in 2010, but in the future, the clean fuels will play a more important role in the future. Let's go a little bit further to see how this clean fuel will play the role. First, this is we have an overview of the combustion mode of the IC engine. The first one, it is gasoline engine, spark ignition combustion mode. The compression ignition mode, it is commonly used in the diesel engine. Now, some new technology. The ideal, it is to produce the homogeneous charge compression ignition, but currently, since it is constrained in a very limited operating range, it cannot run in a very wide range of operating conditions. Therefore, our researchers, the researchers develop the many types of advanced combustion modes, like the reactivity control compression ignition combustion mode, just like I didn't saw here. And another, it is the gasoline compression ignition engine. It is that they use the medium reactivity fuels, but not in the spark ignition engine, but in the compression ignition engine. That type of fuel, it is a little bit like the gasoline, but with a lower research octane number of 60 to 70, but use this similar gasoline similar fuel in the compression engine. This is now currently, this technology didn't need major modification of the engine, but can also obtain a very high efficiency simultaneously. This is the different stratification of the engine, but I don't want to go further in this slide. Yeah, and since we already, for example, our target, it is the GCI mode, the gasoline compression ignition combustion. But what is the best fuel for that combustion mode? How can we formulate the fuel components? Traditionally, in the tradition, it is that the petroleum, the synthetic fuel of the gasoline or diesel in the market, and we purchase from the market, and then we run in the engine. We run in the engine and get our performance, the fuel consumptions, the thermal efficiency, the power, the horsepower output. But in the future, in order to, since we already have a advanced combustion concept, maybe like GCI combustion mode, we don't satisfy on the current gasoline and diesel. The petroleum company, they provide in the therefore, the researcher developed the property-oriented fuel design. It is that based on the GCI combustion mode, what this combustion mode need for the fuel properties. For example, the seating number, the octane number, and the surface tension, and viscosity, blah blah blah, and then we will start the fuel screening. We will develop a fuel compounds database and continue with and follow with a fuel screening process to identify the ideal fuel candidates we need, and then we send this request to the petroleum industry, and they synthetic this target molecule for us. Therefore, in the future, the fuel design process will inverse compared to current condition. Yeah. This is some automatic technology we can use. To formulate the fuel. The first one, it is to generate a molecular structure to build our fuel database. For example, if you want to build a database, it is from methane from hexadecane to hexadecane. It is C16. You cannot list the molecules candidates manually. Therefore, you can use the molecule structure generator to generate by the computer. Yeah, I think it will be more than 100,000 molecules if it is from C1 to C16 molecules. And then in our research group, we develop a high throughput fuel screening tool. Yeah, you develop you already establish a fuel compounds database. We will use machine learning mechanism to predict the fuel properties of this fuel candidates, and then we will use the fuel screening process of different parameters like research octane number, seating number, ignitability, viscosity, and blah blah blah, some physical and chemical properties with screening the fuel, and then to obtain the target field we have, and then we can send this field to the fuel production company. They will use retrosynthetic tool from this target fuel candidate. They will from here and then go to the fuel feedstock. Maybe it is the waste plastic or the lignocellulose of biomass. And also, since if we already obtain the fuel from the synthetic process from the oil company, we will go to the engine test to enrich the fuel properties of our database. And also during this combustion process, there is another technology can be used. It is the reaction mechanism generators. It will help the researchers to understanding the detailed combustion process occur in the combustion chamber more clearly. Yeah, and here during the fuel screening process, the machine learning algorithm will be used. This is how machine learning involved in our research. Here, this is the fuel screening resource. This is from the Department of Energy in United States. They have a project of co-optimization of fuels and engines. Their step, it is a little bit further than us, at least than our research group now. They already complete the final fuel screening too. Fuel screening, they identified the top 10 fuel brand stock for the spark ignition engine, like gasoline engine, and top 12 of the brand stock of the combustion ignition engine. And then for this fuel, it is already under the validation of the engine test and the fundamental combustion test. This is the reason why I say they go a little bit ahead than us, because at least for me, I didn't arrive this step currently. And you saw here, this is they propose a prenup, one type of one type of alcohol. There is a very interesting phenomenon. You saw that because now the gasoline we sell in the market, it is usually it is number 92, number 95, and number 98 of the octane number. But if we saw that, we saw here, if we brand we use addictive to increase the octane number of a base fuel. We saw that if the addictive, it will have a octane number of 110. If we add it into the base fuel of the base gasoline, there is usually there is three types of possibility. The first one, it is that as the addictive adding, the octane number will increase linearly. If another negative effect, it is that you even get a bad, get a worse octane number. This is the antagonistic branding effect, because it is compared to the linear branding, it is still worse than that one. The ideal one, we investigate, because for the compared to the 98 gasoline to the 95 gasoline, there will be more iso-octane component in that composition. It will also introduce the synergistic branding impact. That means if this is the 100% of the octane number, this is 100% of the base gasoline. When you're increasing the octane number proportion, finally, what you can obtain, the ideal condition, it is that the 100, the octane number of 100, you never exceed of the octane number. But for the prenup, it is another story. It will have a hyper boost impact. That means during your branding process, it will have a hyper boost impact here. It is even higher than the pure compound of the prenup. This is the reason why now in United States, they will use many researchers, especially those under the DOE, Department of the Energy Project. They will, many of the researchers, they are focusing on this prenup. I think in the future, we can go to have a look on this this field. It is very promising in the future gasoline engine. Yeah. And for the concluding remark of the prospect of internal combustion and fuel, it is that I cannot say the IC engine if we will die in the future 10 or 30 years, but I can say it is that if we didn't collaborate with the hybrid vehicle, it must be die. But if we can embrace this opportunity with the hybrid vehicle, it will be alive in the future, because it will get a new development opportunity, because as we discussed previously, the IC engine will no longer run in the full engine map. It just needs to run in a single ponds or a few single ponds. And for the fuel aspect, the the raw sentence of it is a fossil fuel will have to underwrite a transition to other source of energy. That means the fuel complete a transition from the fossil fuel to the sustainable fuel. For example, the fuels from the biomass, from the waste plastic, or from the sustainable energy like electrolyze the hydrogen, the water to produce hydrogen, and combine with the CO2 to produce the liquid fuel. This is the will convert from the fossil fuel to the carbon neutral fuels. This is the trend in the future. And also, I would like to because currently it is very popular of the intelligent connected vehicle in China, and also many researchers also focusing on the automated driving, especially the self-driving. I want to answer the question is that what is the relationship between them? First, we introduce the intelligent connected vehicle. It is that more exactly, it is that vehicle connected to everything. For example, your vehicle will connect it to the network, the transportation management system. It will feedback you the some signal, some information of the path of the route, and also you will get have a communication with your vehicle that is labeled to your that is your label, and also you will also get the vehicle to the pedestrian. You will know that your vehicle will know that okay, I cannot crash the pedestrian, and also for the light or other infrastructure, your vehicle will know in maybe 100 or 200 meters away what is the traffic light. It is green or red. You will get a signal or the information from them. It is the vehicle to the infrastructure, and we can say that this is the nature of the intelligent connected vehicle. But what they can provide us, it will improve the road safety by the vehicle to vehicle connection communication. It will improve the traffic efficiency because the traffic light will the intelligent transportation management system already feedback to you. Maybe 500 meters away, there will be a transfer to red light soon. You don't need you can maintain your cruise speed. You don't need to accelerate. It will increase the traffic efficiency, and also it will lead you to a more efficient route to avoid the traffic jams. And also it will improve the environmental consideration, and also improve the competitive, because the improve the competitivity is that because in China it want to complete a new industry revolution. It is that introduce the information in the different industry sector. Of course, the automotive sector, it is just a very, very small sector in a country, but it is a part of the partial of the story in China. The information must be go into the industry sector, and also the consumer acceptance, because it is that the intelligent connected vehicle can provide the driver, can feedback the driver many information, can aid their driving operation, and aid their driving behavior. And also we go here. This is the automated driving from international SAE. There is 6 levels. The first level, it is the driver. The first one, it is no automation. It is that you need to keep your hand and eyes, no driving aided technology in your vehicle. the first layer, it is that there is some, maybe it is AD parking. This is the first one, but you still need to put your hand and your eye contact in the vehicle. And partial automation, it is that it will very ready for some control. Some control, maybe it is that if some provide you some distance information to your to the driver. Yeah, this is will go a little bit further, and other driver aided information will provide it into the self-driving, but your hands and eyes cannot move away. And the third and fourth one, it is that increasing that the characteristic in the level 3 and level 4, it is that you can directly remove your eye. You don't need eye to watch the road condition. You just need, but you still need to put your hands on the wheel, on the driver wheel, because if there is some disaster, the driver will take back the control right from the automated system. But in the full automation, it is that you can remove your eyes and hands out of the vehicle. You can stay in the car, but you're reading or playing. And this is the automated vehicle. It will generate, it is the LiDAR. It is usually it is used for detect the it is for the long distance to measure the distance of provide the distance of the vehicle in this area. And there is some radar. There is long-range radar and short and medium-range radar. Different types of radar. It is also used to measure the distance, but its angle will be a little bit different. It is a complement with the LiDAR. And the camera, it is used for the self-driving to convert it, and the CPU will convert the figure information from the camera. It will post-processing and will extract the elements. For example, the pedestrian, the house, the dogs, or some barriers in the road or the lane. It will provide the information. It will quantify it will change the figure into the digital information and go to the CPU, and the CPU will embed the AI algorithm to implement some actions to control the vehicle. But we can saw that since the intelligent connected vehicle, what is the core? It is that to obtain the information. Therefore, all the information obtained from the automotive or self-driving vehicle will this information will finally in the future will send to the center of the intelligent transportation management system, and then feedback to other vehicles or other individuals. This is the reason why I think that autonomous finally will be connected into the intelligent transportation system. In the future will be a big data future. And also, in addition to the self-driving, and another very important technology of the high definition map, it is a very it is necessary for self-driving. It is that the first function, it is that to extend the sensor range. For example, you see here, this is the vehicle sensor. It's a sensor, it is very limited. Maybe it is 20 meters away. But if some suppliers in China, they already can provide a high definition map, like the Baidu and Gopta map or Tencent map. They already can provide a very high accuracy, high resolution map. And then to help the driver to extend their sensor range. Now it is a very necessary technology. Another, it is that sense to provide another very good localization position of the vehicle, because if there is no vehicle around you, you are in the rain, and then that means your sensor didn't can obtain very minor information. But if the vehicle can obtain the high definition map from the satellite, and then it will be provide a more accurate positioning of the vehicle. And also, this is another application scenario, because if you go to a very long distance tunnel, maybe it is 5 kilometers. When you go inside, you will lose many information and high definition map can improve the sensor perception in the tunnel, in addition to the radar and LiDAR and the camera. And also in the highway, it will be more safe to complete the path planning. Therefore, this is the 4 major roles of the high dimension map. Yes, okay, thank you. Thank you for your listening. I stopped my presentation here. Thank you. Yes, I saw from Stephanie. When do you think the majority? I think the level 5, it is not very possible,